In the previous video, we learned 3 rules of reflection for concave mirrors. We learned that a ray of light that travels parallel to the mirror will reflect and pass through the focal point. A ray of light that goes through the focal point on the right of the mirror will reflect and travel parallel to the principal axes. And a ray of light that goes through the center of curvature will reflect right back upon itself. Then we use those 3 rules of reflection from page 10 at the very bottom in order to do the first case, the diagram on page 11, predicting where the image would be located and what sort of orientation, size, and type it might be of whenever the object's located beyond C. So right now what we're going to do is case 2 from the same page 11. If you turn there, page 11, case 2, we're going to repeat the process, this time for the object being located at the center of curvature. So in order to do that, I need to pick a point on the extremity of the object. I'm going to take the upper extremity, and I'm going to find out where light from that point would intersect. That location of intersection is called the image location. So to do so, I draw my first ray of light parallel to the principal axis as such. That's the incident ray, and the corresponding reflected ray is the ray that travels through the focal point after reflecting off the mirror. So I line it up as accurately as I possibly can, and I draw my reflected ray as such. Now my second set of incident and reflected rays is the ray that goes through the focal point on the ray of the mirror, hits the mirror, reflects, and travels parallel to the principal axis. And so I line my ruler up with the top of the little boy's head in the focal point, and I draw my incident ray on the way to the mirror. You'll notice that whenever I draw these light rays, they're actually rays and not lines. That means they have arrowheads located on them in order to represent the direction of motion that they're traveling. Now I'm going to reflect this incident ray such that it travels parallel to the principal axis. And when I do, it will eventually intersect at a location right about here. Now what I have to do is draw the complete image. And the complete image of the little boy when he stands at the center of curvature is right at that same location. It goes downwards. It's just about the same size as the little boy himself. So I could do a comparison there, and they're just about the same size. So for location, I say right at the center of curvature. For size, I say neither magnified nor reduced, but the same size. For orientation, I observe that it's an inverted image, and because the light rays are actually coming together at this location, if this were a smiley face light bulb instead of a boy, and I placed a note card right there, I would see an image of a smiley face light bulb right there on my note card. Images such as that, which are projectable, are what we call real images. Now you've seen case 1 and you've seen case 2 on page 11. What I would like you to do to finish up this lesson is turn the page over and do case 3 on the very next page. I'll see you in class on Tuesday. Thanks.